You ship a chat feature on Friday. 10,000 conversations run through it in a month. You do the math before launch. A few hundred words per message, 10 messages per conversation. You budget $1,600. The invoice arrives at $4,700. Your traffic matched the estimate exactly. Your token count did not. Nothing broke. No bug. No runaway loop. The tokens you counted were never the tokens you were billed for. Start with the unit you are actually paying for. A token is not a word. It is a fragment of text that the model treats as one symbol. Take the sentence, "The engineer reviewed the deployment pipeline carefully." Common words like "the" and "a" become one token each. Longer words break apart. Deployment might split into deploy and meant. Pipeline might split into pipe and line. The model never sees letters. It sees a list of integers, one per fragment. There is a rule of thumb for English. Anthropic publishes it directly. One token is roughly 4 characters, or about 3/4 of a word. That rule is where your estimate went wrong. It holds for plain English prose written by a human. It does not hold for code. It does not hold for JSON. It does not hold for identifiers, or for any language that does not use the Latin alphabet. Every one of those costs more tokens per character than the rule predicts. So why does the split happen the way it does? Most models use byte-pair encoding. The algorithm is short enough to hold in your head. Take a large pile of training text. Break every word into single characters. Count every adjacent pair of symbols across the whole corpus. Find the pair that appears most often. Merge it into one new symbol. Now count again and merge again. Repeat until you have the vocabulary size you want. Then freeze the list of merges. That frozen list is the tokenizer. 2 properties fall out of that design. First, there are no unknown words. Any string you send decomposes into fragments the vocabulary already contains, down to single bytes if needed. A typo, a variable name, a word invented yesterday. All of them encode. Second, the vocabulary stays bounded. A model with 100,000 token vocabulary needs 100,000 embedding rows, not one row for every word in every language. Frequency drives the merges. Text that looked like the training data compresses well. Text that did not, does not. That last sentence is where your bill lives. Look at a small JSON payload. 3 fields, a user identifier, a role, a region. Strip out the values and count only the structure. Braces, quotes, colons, commas, indent spaces, line breaks. 32 characters of pure punctuation. None of it carries meaning to your user. All of it is billed, and the identifier is worse. A UUID is 36 characters of random hexadecimal. Random hex has no frequent pairs, so byte-pair encoding found almost nothing to merge. It shatters into many small pieces. Non-Latin scripts cost more for the same reason. Training corpora are mostly English, so English words earned merges. Most Devanagari, Japanese, and Arabic characters did not. Now add how UTF-8 works. A Latin letter is 1 byte. A Devanagari or Japanese character is 3 bytes. When the tokenizer has no merge covering that character, it falls back toward bytes. 1 character can cost up to 3 tokens. So the same meaning expressed in Hindi instead of English can cost several times more to send. Measure your own languages, and measure again when you change model version. Anthropic documents that Claude 4.7 and later use a newer tokenizer, producing about 30% more tokens for the same text. Every provider bills input and output separately, per million tokens. Claude Opus 5 is $5 per million input tokens, and $25 per million output. Claude Sonnet 5 is $2 and $10. Claude Haiku 4.5 is $1 and $5. GPT 5.6. Soul is $5 and $30. Gemini 3.1 Pro is $2 and $12. Prices change. The date on screen is the reference. Look at the pattern. Output costs 5 times input on the Claude models, 6 times on GPT 5.6 Soul, and on Gemini 3.1 Pro. The asymmetry is not arbitrary. It comes from how inference runs. Input tokens are processed in prefill. The model sees them all at once and runs them through in parallel. Output tokens are generated one at a time. Each new token needs its own full pass through the model and cannot start until the previous one finishes. Parallel work is cheap, sequential work is not. Here is the part that produces the 3 times. The API is stateless. It has no memory of your last call. When a user sends their 5th message, the model does not remember messages 1 through 4. So your client sends them again, the whole conversation, from the beginning, in the messages array, every single turn. That is not a bug in your code. That is how the protocol works. But it means the thing you are billed for is not what the user typed. It is what you send again. Walk it. Set the fixed part aside for one moment. A user message runs 200 tokens. A model reply runs 600. Turn 1 sends 200 tokens of history. Turn 2 sends the first exchange plus the new message. That is 1,000 tokens. Turn 3 sends 1,800. Turn 4 sends 2,600. Each turn adds 800 tokens to every future call. Add all 10 turns together. You have sent 38,000 tokens of conversation. The user typed 2,000 of them. That growth is quadratic in the number of turns. Double the turns, and you roughly quadruple the tokens. Then add the fixed costs. Your system prompt is billed as input tokens on every single call. Not once per session, every call. Say it is 1,500 tokens. Your tool definitions are also input tokens on every call, whether the model uses them or not. Say 800, and when you pass any tools at all, the provider inserts its own tool use system prompt. Anthropic publishes the exact size. On Claude Opus 5 with tool choice set to auto, it is 286 tokens. That is 2,586 tokens of fixed prefix charged 10 times. 25,860 tokens. Add the 38,000 of conversation. Your real input is 63,860 tokens. Your output is 6,000. On Claude Opus 5, that is 32 cents of input and 15 cents of output. 47 cents for one conversation. Your estimate counted only the messages, 2,000 in, 6,000 out, 16 cents. That is close to 3 times the estimate. And that is before retrieval. If you are running RAG, you stuff retrieved chunks into every request. 5 chunks at 800 tokens each is 4,000 tokens per call. Across 10 turns, that is 40,000 more input tokens and 20 more cents. Now multiply. 47 cents times 10,000 conversations is $4,700 a month. Your estimate of 16 cents times 10,000 said 1,600. Nothing broke. You were counting the wrong tokens. 3 levers cut this. First, prompt caching. You mark a stable prefix with the cache control field. The provider stores the processed prefix. Subsequent calls that reuse it are billed for cache reads instead of fresh input. On Anthropic, a cache read costs 10% of the base input price. Opus 5 input drops from $5 per million to 50 cents. The write costs more once, at 1.25 times base for the 5-minute cache. It pays back after a single hit. Second, stop sending unbounded history. Keep the last 6 turns and drop the rest. Or summarize older turns into a short block and send that instead. This is the structural fix. It turns quadratic growth into linear growth. Third, route by difficulty. Claude Haiku 4.5 is $1 and $5 per million. That is exactly 1/5 of Opus 5 on both sides. The same 10-turn conversation costs 9 cents instead of 47. Send simple turns to the small model. Send hard turns to the large one. None of that matters if you do not measure. Every response from the API carries a usage object. Read it, log it. On Anthropic, it gives you input tokens, output tokens, cache read input tokens, and cache creation input tokens per request. Store those 4 numbers next to your request identifier. Within a day, you will know which endpoint burns your budget. You will know your cache hit rate. You will stop estimating from message counts because you will have the real numbers. A token is not a word, and your bill is driven far more by how many tokens you resend than by how many anyone types. Go open your logs, find your longest running conversation. Divide its total input tokens by the number of messages in it. That single number tells you how much history you are paying to repeat. If it is climbing, you have found your bill. One more thing, do this before you optimize anything. The lever you reach for should follow the measurement, not the guess.